This project considers sponsored data, a new form of mobile data pricing. It is joint work between Carly Jiawang and Meng Jiang at Princeton and Sang-Tae Ha at the University of Colorado. Sponsored data allows content providers to pay for users' mobile data usage. In January 2014, AT&T announced a sponsored data initiative in which any content provider would be able to work with AT&T to sponsor its traffic. T-Mobile announced a targeted program in June 2014 where they would sponsor all music streaming. Users can use sponsored data either by selecting sponsored parts of an app, as in the news stories on the left, or selecting from a range of apps, as in the right screenshot. Sponsored data has generated controversy in the United States, particularly over its implications for net neutrality. While data subsidies do not affect user quality of service, they might provide disproportionate advantage to larger content providers that are more able to sponsor data. As we show in this work, however, this inequality is tempered by sponsored data's ability to make mobile data more affordable for users. Content providers, or CPs, have an incentive to sponsor data since that increases user demand. Their benefits, however, take different forms. Some CPs receive advertising or subscription revenue from users, and more data allows them to collect more revenue. Other CPs benefit from goodwill or publicity when users consume more data. Enterprise apps can benefit from greater user productivity if users use the apps more. We model pricing and demand under sponsored data using a three-stage hierarchy. First, ISPs choose access prices for users and CPs, and then CPs choose the fraction of data to sponsor, and finally users choose how much data to use. To solve for the optimal actions of each party, we start from the end users and work backwards. Users choose their demand as a function of CP sponsorship and ISP prices so as to maximize a two-part utility. One part represents the utility of consuming data, and another the amount paid for this data. Similarly, CP's utility has a component for their benefit from user demand, and another for the amount paid to sponsor data. ISPs choose the access prices so as to maximize their total revenue, subject to a network capacity constraint on total demand. The parameter C represents the weight of users' utility from using data, relative to the cost of data. For lower C, i.e. more cost-conscious users, demand can increase more with sponsorship. Thus, mobile data becomes more affordable for cost-conscious users. Similarly, the parameter D represents the weight of CP's utility from using data, relative to the cost of data. For higher D, or less cost-conscious CPs, utility increases more with sponsorship. We also find that the ratio of CP to user utility decreases with sponsorship, as shown in this graph. Here we estimated user and CP behavior parameters from a small pricing trial with 20 users. The decrease in the ratio of CP to user utility implies that users benefit more than CPs from sponsored data. If we consider the full range of users and CPs with these estimated behavior parameters, we find that some users spread their demand across CPs more evenly with sponsorship, but not all users do so. We measure evenness using Jane's index, with turquoise bars representing evenness after sponsorship. Similarly, most CPs will receive more even user demands after sponsorship. Thus, sponsored data can have complex effects on the distribution of user and CP demands. It can induce more even demand spreads and make data more affordable.